episode of this digital online series, and today we'll be looking at Python with OpenCV again. Right, so previously we looked at the different kind of variables for the Kenny image filtering. So we did a bit of stacking of images as well as scaling of the frame. Right, so today we'll be looking more into the different type of filters, and in particular the blurring filters. So why we want to blur is to reduce the noise in the background, as well as to make the distinct features that we want to observe more profound. Right, so now let's take a look at the code. So previously we had done 3 Kenny frames, but today we'll be looking at filters first. So filters will come before the Kenny image processing. So let's just comment this out. So three commas will mean, three inverted commas will mean we comment out a chunk of code. So it begins with the 3, it ends with the 3. So alternatively we can use double and just corresponding. Right, so let's begin. So we want to apply these blur filters on an image that is in grayscale. So let's do this. Let's open this object. So first we want to try the most basic filter for blurring. It's called just a blur. It's the homogeneous blur filter. So let's take a look at. So we just call this blur frame equals to c2.blur, and we pass in the argument. First is the frame as usual, and we pass in the size that we want to blur. So I'll explain this a little bit here. So what this does is creates a 5x5 matrix, and then it will take it as one pixel, so called like one frame, and then all these 5x5 pixels in the frame will be averaged out. So it will take all the values in the frame and then distribute it, divide by 25. So we'll just try this, and I think it's easier to see the effect that it will bring about. So let's put this here. So this blur. Then we'll also look at how the different kinds of values will affect the blur that we bring about in this. We'll run the model. Notice the little edges that we have. So in between color boundaries, we have a little bit of blur here. So let's scale it down. I think we need to scale the frame down to see it better. Just pass in the frame. Right. So later at the end we'll print out the scaled frame. So let's go. And let's see. So this is, let's have a frame for comparison. So we go just passing gray. So let's take a look at the different effects that will cause. Oh, I forgot to scale it down. So let me just the same scale. Oops. The scale gray frame. Run it. So you can see the distinct difference between the two frames. blurring of the image. Right. So what it does is it takes a 5 by 5 matrix. So for example, this small area here is a 5 by 5 matrix, and then it will take the average values of the pixels and give you the average for all the pixels. So it replaces each square of 5 by 5 pixels with average of it. So if it's a black and a white boundary, it will appear to be grayish, in the middle of black and white. So let's try it with something which is larger. It would maybe we do 20 by 20, and we compare it against so we blur 20 and blur 5. Let's keep it to our original that we used just now, which is 5. And let's click. And you can see the effect of the 20 by 20 matrix blur. It's really much blurrer as compared to the 5 by 5 kernel matrix blur. So this will definitely give us a very low resolution of image, and if you're looking for very rough features, this will be a good way to categorize it. If you're looking for like distinct color differences, or maybe like just a silhouette of a human being, this would be a good filter to use. Okay, so before we end off today's session, let's take a look at how the two frames will look like side by side, the one with the blur and the one without. So let's take a look at the two side by side. So the one on top is the original image just in grayscale, and the one below is the one which has been applied a blur filter on it. So that's how it is. And in the next session, we'll be looking at different type of filters we have and the specific applications of each filter. So to then, all the code will be found in the comment section of the GitHub link, and see you next time.